Yeah, okay. So what I was saying to Michael is that one of the things we're talking about, the 16 components of that can carry energy in my theory, and Michael was saying that 16 is more than humans can cope with, and I said, yeah, you and me both, yeah, absolutely. And what's given me a lot of hope on this whole working is that is this realization for me that it's more complex than 4D. That really, it's a multiply layered set of three-dimensional systems that one is working with. And 3D, I was saying, as a millions of years of monkey evolution have given me quite a basal understanding of how 3D works, jumping around the trees. So 3D I can cope with. And then Michael was asking what those 3D things are, just a reminder of what those 3D things are. And okay, what I was saying is that the base one is coordinate, it's position, it's whatever that is, because one's sitting in some sort of matrix of something. One cannot know what that matrix is, because being a part of it, you can't see it. All that one sees are changes with respect to it. And the changes, of course, are very small compared to the thing itself. So you have some system, space and time, which tells you where and when you are. But in fact, where and when you are is always just in one place and at one time. Where and when you are is always right now, right here, at the pinnacle of the present. And then the universe which one inhabits from that is something which is three-dimensionally. It has a couple of things. It has a magnitude of how far away things are, in fact, how far ago things are. It's only your past affects you. How far ago things are in meters or in seconds or in minutes. So there's something being 8 minutes ago. And then its direction, theta and phi. That's the three-dimensionality of an underlying flow within that four-dimensional system. But what is that flow? That flow is, in electromagnetism, it's characterized by being the vector potential, which is thought not to be physical in most elementary textbooks. Although the fact that it is physical is portrayed by the fact that I think such things as the Aharonov-Bohm effect. But anyway, if one has a flow of this, or really more properly something more like a tension. So if one imagine there being a matrix and there being some sort of vector change in that, where as a function of position, perhaps the spacing changes a little bit. Spacing being what I was measuring, the underlying fabric of the universe. So, but that's something which is potentially unobservable, and which has a vector for it has a three-dimensional form of in space, and on top of that, one has this relationship between the distance things are away in time that's given by the speed of light for things that are experienced. So, but that dimensionality of this matrix in which we sit is three-dimensional, not four-dimensional. The four-dimensional part of this comes through inverse time, which is a frequency, which is a vibration within that. So you can imagine that as just being some sort of wave in this thing, I suppose. Anyway, but so the first three-dimensionality is three-dimensionality of three is the dimensionality of space, where stuff is, the relationship between things. And that might be defined by the other dimensionalities, but it can be measured. We can measure it by doing, for example, timing of how fast it takes light, how much time it takes light to traverse point A to point B. So that's the first three-dimensionality. It's the three-dimensionality of space. Now there are three related three-dimensionalities that have to do with divisions between these objects. So you can have a division of space by a perpendicular space, or you can have division of space by time. So the simplest division of space by time is velocity. And the dimensionality of velocity is also three-dimensional because it's dx by dt, dy by dt, dz by dt, and not dt by dt, which is a scalar. So velocity is also a three-dimensional object, always has been. But if we take the derivative with respect to time of the vector potential, for example, vector potential A, dA by dt, well, that's the electric field. And there are three of those, dAx by dt, dAy by dt, dAz by dt. So there's a three-dimensionality of electric field. This is the second level. It's the one one feels when one touches a table or something. It's really electric field one's feeling. You're not feeling position. The things are distributed over a set of positions, but you're feeling the field, feeling the force. And that force is essentially electric for those things. But also there's ax by dy minus day by dx, which is the z component of the magnetic field. So the cross terms, the things we call cross product terms, conventionally the curl of A, the curl of the vector potential is the magnetic field, or minus the magnetic field. One of them has a minus sign in conventionally, depending on which convention you take, because there's more than one. So, but nonetheless, d space by d perpendicular space is, or are, the components of a three-dimensional space, three components of magnetic field. Now, physical objects have electric field and they have magnetic field. And they also have position. They are held in position by interactions with respect to one another by a force minimum in a crystal, in an object which forms the world in which we live, a planet, we're sitting on. So, so that dimensionality is not independent, because they're different. It's independent in that it's linearly independent. You can't add any amount of electric to get magnetic. You can't add any amount of space to get electric. They're linearly independent. They're separate components. But it's not independent in the sense that they're not connected. They're connected by a set of electrons, which may or may not be the Williamson equations, right? So in terms of the way that they transform one into the other, the energy is transformed from one kind into another. And that transformation also has to do with interaction, and it's only interaction that you can see. It's only interaction that is experience. If things don't change, you don't see the not change. Only see the change. Anyway, so that's electric and magnetic. But the most fundamental one in terms of quantization is not electrical magnetic, and it's not even space, because space is kind of continuous. The one where quantization takes place is the fourth of these, and that's angular momentum. So that is a motion, dx by dt by dy, how that changes with respect to a perpendicular direction. So that's a trivector component, and that's saying how much things go around and around in circles. Now, apparently, the universe in which we live, and quantum mechanically, one has these things called quantization rules. It's a rule. No, it's not a rule. It's just bleeding obvious if you think about where it comes from. For something to be an object, it has to be in phase with itself when it comes round. And that is the essence, essentially, of all quantization. It's angular momentum. And hence, half h bar and h bar, half h bar for doubly covering things like electrons, for fermions, h bar for anything that's a boson, h bar, 2h bar, 3h bar, for anything that's a, or 0h bar, for a dielectron, for example. These things are all have a quantum condition associated with them that has to do with their phase, internal phase integrity. That's where it all comes from. That is, it's not a rule. It is a continuity condition, an existence criterion for an object which is truly something which is a constant state of flux on the basis of some background, something which is continuously in motion. Frequencies that are a bit too high for us to comprehend. Even for light particles, we're talking over 10 to the 20 hertz. So to us, these things look like, and this is what happens in Dirac. If you look at the solution in Dirac, what it is the first term is a very rapid speed of light motion, which is vibrating in all dimensions, x, y, z, and t. And then the second term is a half mv squared in the energy term. It's just the motion of the object. So beautiful derivation by utterly wonderful Dirac. And absolutely everybody should be, considers themselves a physicist, should be tied to the book and not allowed to come out of the room until they got that. Utterly perfect, utterly beautiful, utterly central to understanding what's happening in terms of objects. They only exist if they move for you. Of course, there is an underlying existence, but measuring that has interesting problems. So one doesn't know what the matrix is. The matrix could be a computer program, it could be fabric of space-time, whatever that is. It could be high energy, it could be low energy, it could be broken down at some level. One doesn't know until one doesn't know. At the moment, I don't know. Maybe other people do know, but I don't know that they know. So those are the four three-dimensional universes in the kilo. Position, x, y, z, ex, ey, ez, the tension in the electric field, electricism, as we've just decided to call it, magnetism. Come on, guys, anyone else listening to this? Is there a word that corresponds to electro, to magnetism for electro? In any language, come on, give me a language which has got a proper word for that. We came with electricity, but electricity is the flow of electrons. It's what you get with it. That's nothing to do with that. It's not three-dimensional. It runs along a wire. Anyway. Just gobsmacked. There's no word for it in English. I'm gonna look it up now. I'm going to go crazy about that. Looking it up now. That's. But the main one, spin. And it's spin that we were just talking about with the conjecture as to how to improve our superconducting experience up to room temperature. So there we go.